visual way of seeing whether or not you have an outlier. Similarly, if you had a very, very small number, you get this graph, and that's called skewed left. And there you go. Outlier on the left, long tail on the left is skewed left. And there you go. Okay. So, any questions about these things? All right. So, one last thing for today. Z-score. So, Z-score, the thing to keep in mind as we talk about the Z-score is that the Z-score means something. The Z-score means the number of standard deviations from the mean. So, what is that in practice and how is it useful? So let's talk about an example. Suppose a class takes an exam. The mean score was a 77 and you got an 85. Is that good? Well, seems like it's good. It's not bad. But the real question is, how good? If the average is a 77, how good is it to get an 85? It is above average, so it's good. But how good is it? So what I'm going to tell you is that it depends. Is it possible that you got the highest score in the class? Could be. In that case, how good is an 85? It's awesome. On the other hand, maybe the scores went anywhere from like 30 to 100, and then how good is an 85? Well, it's good, but it's not amazing. So what this depends on is how spread out is the data. If all the scores are in the class are from 70 to 85 and you get an 85 is awesome. But if the scores go from 30 to 100, an 85 is good, but it's less awesome. So what we need to measure is how spread out is the data. And this is what we talked about last time. This is what you guys got headaches doing in the homework, was calculating standard deviation. So we're going to use standard deviation to figure this out. So how do we do that? Suppose the standard deviation is 4. How many standard deviations above the mean are you? Well, first of all, how far above the mean is your test score? It's 8 above the mean. So how many standard deviations is that if the standard deviation is 4? Right, and why is it 2? Yeah, exactly. Okay, there are 2 4s in 8. Now let's make it a little trickier. Jerry got an 88. How many standard deviations above the mean is his score? So what's the first thing we need to do? First thing we need to do is figure out how far above the mean is Jerry. So I'm asking, how far above the mean is Jerry? He's 11, and how did you get that? Right. Now the next thing you need to do is figure out how many standard deviations is 11. So how do you do that? Yeah. Because what is it that we need to figure out? How many 4s does it take to make 11? As hopefully we all learned in middle school, that's just a division problem. How many 4s go into 11? It's 11 divided by 4. So, I mean, yeah, if we work it out, it's 2.75. But I mean, I want you to see how to set it up. So, we now have all the basic elements of how to set this up. We did 88 minus 77, and then we divided by 4. But we know what each of these things is. What's 88? In statistics speak, what's 88? It's Jerry's score, but what do we call that in general, in terminology? Or another way to put it, what's 77? 77 is the mean. And what's 88? 88 is the data value. And what's 4?
Deviation.
The standard deviation. We have notations for all those things. What's the notation for data value? X. What's the notation for the mean? X bar or mu, depending. And what's the notation for standard deviation? S. So there's our formula. That's it. And again, the notation depends on just whether you're working with a population or a sample. But it's the same idea either way. It's data value minus mean divided by standard deviation. And in fact, it's almost better if you remember it that way, because knowing it that way is going to help us for the rest of the semester. We're going to be using this for the rest of the semester. Yes. Okay. So for example, let's find the z-score of 47 if mu is 38 and sigma is 5. How do you set this up? I'm sorry?
47 minus 38.
That's it. 47 minus 38. And remember, this is what z equals, so I always set it up like that. Z equals 47 minus 38 over 5. It's your data value minus the mean divided by the standard deviation. 47 minus 38 divided by 5. If you work that out, it's 9 over 5, which is 1.8. And remember what this means. This means 1.8 standard deviations above the mean. Okay. And what about this one? Over 4, because that's the standard deviation. So this works out to negative 10 over 4. That's negative 2.5. So negative 2.5, what does that mean? Yeah. 2.5 standard deviations, but that negative is telling us that we are below the mean. Okay. All right. So that's what that comment is. Okay. So I know I'm essentially out of time. I want to cover 2 little notes really quickly. All right. Which exam score is relatively better? A 75 when the class average was 68 with standard deviation 4, or an 89 when the class average was 76 and the standard deviation was 12? So right off the bat, it sounds like the 89 is better. But in fact, if you want to do a relative comparison, you have to use the z-score. So in the interest of time, I'm not going to work it out. It turns out that 75 has a better z-score, so relatively, that's a better exam score. It's more standard deviations above the mean. Okay. And again, sorry I'm rushing in the interest of time. Okay. Last bit. So now we're going to go backwards. Find the data value, which is 2 standard deviations above the mean, if mu is 32 and sigma is 6. How do we do this? Sorry? Is 2 your data value? Yes. 2 is the z-score.
That's what she meant.
Oh, that's what you meant?
Yeah,
Oh, okay.
she was setting it up.
Oh, okay. Oh, I'm sorry. Maybe I didn't hear the rest of what you said correctly. So you said 2 equals... Oh, yeah, I didn't hear the rest of what you said. I'm sorry. That's right. Yes. Okay. So you could set it up like this, use the formula we had before, and then just work out the algebra. But there's a better way. I'm going to kick this to the side because there's a better way. Read it. 2 standard deviations above the mean. Well, what's the mean? 32. And we want to be 2 standard deviations above that. How do you get that? Plus, well, you're going to be above means plus something. So what are we adding? Right, and how many 6s are we adding? 2, so how can we write that down? 2 times 6. 2 standard deviations, and add that onto the mean. And that's exactly what we're being asked to find. And remember, we're finding a data value, so this is x equals. Right, if you work this out, 32 plus 12 is 44. But notice that if you go back to the way we originally wrote it down, all you have to do is translate it and you have your formula. Because what is 32? Is the mean. And what is 2? Number of standard deviations, not the standard deviation. What is 6? 6 is the actual standard deviation. What is 2? How many standard deviations, and what's the notation for that? What tells you how many standard deviations? What tells you how many standard deviations? That's your z-score. That is the very meaning of what a z-score is. So, there's your formula. Mean plus z times sigma. And that gives you your data value.
If you was to do it like that, you'd be able to find it.
Yes, these two, the formula to find z and the formula to find x are equivalent. You can just do algebra and turn one into the other. Notice you just do x minus mu and then divide by sigma and you get z by itself. But each form, this is a formula that directly gives you x, and the other one's a formula that gives you directly z, but they're equivalent formulas. Okay.